So for part A, OP is equal to 2 negative 7. Okay, OQ 8 3. Need to think one or not? This question need to think? No need lah, no need to think one. Just put on the answer only. Okay. Then we also require PQ. It is not explicitly stated what the vector of PQ will be. So without drawing, I don't even need to look at the diagram. How do we get the vector PQ from my two available vectors already? Can you write an equation? PQ equals to? Can you fill in the blanks? I prefer to do it this way. PO plus OQ. Okay, which what Damira has suggested is actually negative OP. Was this what you wanted to say, Damira? Yeah, then plus OQ. Okay, so just fill in the blanks. Negative OP will be 2 and negative 7 plus 8, 3. Combine them together, 8 minus 2, you get 6, 3 plus 7, 10. Simple. Then now we require OM. What information did they give about point M? M is the midpoint of PQ. M is the midpoint of PQ. Okay, this is where the diagram can help us. Since M is the midpoint of PQ, then I'm able to put dashes like this to indicate that they are of the same length. Then I want the vector OM. So because I do not know the coordinates of M, I can't simply write down what OM vector is. So I need to go other way. I need to go another way. So your job now is to rewrite OM in terms of other known vectors. So instead of going directly, how else would you suggest that we go from point O to point M? It is definitely going to be a longer route. You can try anything that you like on the screen, and I'll do it for you. OP, you want to go to OP first? O to P, and then O to P, then P to M. Okay. Do we have OP already? Yeah, okay. So OP was settled already. That is 2, negative 7. Then what about PM now? What information do we have about PM? So it is half of PQ. Right, PM is actually half of the vector PQ. So all this information, write it down. It will give you marks. So it is half of PQ. Now so far so simple, PQ. Then we already have the vector PQ over here. Just put it in. 2, negative 7 plus half of 6, 10. So 2 plus 3, 5. 7 plus 5, negative 7 plus 5, negative 2. Then we take a look at the diagram. If it is drawn to scale, right, then the coordinates should be x coordinate 5, y coordinate negative 2. If it is drawn to scale, then let's take a look. M over here, 5, negative 2. Yeah, it corresponds. So we are able to use vectors to help us solve this type of coordinate geometry questions quite quickly. Is there another way to find the vector OM? Given that we have the coordinates of Q to be 8, 3, then we have the coordinates of P given to be 2, negative 7. Another way to find the coordinates of M? You all learn midpoint, right? Midpoint? Yeah, I remember teaching your class before. How do we find the midpoint of a line segment? So my line segment is PQ. I want to find the center point. What are the coordinates? Huh? Add what? Both, which one? There's x and y. 8 and 8, 3. 8 and 2. 3 and negative 7. Does that make sense? If you don't remember your midpoint calculation, then we just use logic. See, M is the center of P and Q. P has the coordinates 2, negative 7. Q has the coordinates 8 and 3. If I want the center, I want whatever is right in the middle. So I compare the x coordinates. 8 and 2. 2 is over here. 8 is over here. What is the center of 2 and 8? What is the middle of 2 and 8? How do we decide what is in the center of 2 and 8? And 8 plus 2 divided by 2. So that's like the average. We're like taking the average. 8 plus 2 is 10. Divided by 2 will be 5. Okay, then the center must be at 5. Understand? Then now I want the y coordinate. Logically, what must it be now? 3 plus negative 7. Then divided by 2, right? Although it is a negative 7, but we are just effectively finding the average. So 3 minus 7 is negative 4. Divided by 2, negative 2. This value over here. So 5, negative 2. Can? Okay, now part B. Magnitude of OM. What is the magnitude of OM? What is the formula to use for the magnitude of OM? Pythagoras theorem. Okay, so how do we write it down? Magnitude OM. Nobody wants to spell magnitude of OM, right? So just use these short forms, but make sure you know what you're doing. So this must be the given by square root of M is here. So the coordinates we found out to be 5 and negative 2. Then we can use this information, plug it over here. 5 square plus negative 2 square. That gives us square root of 25 plus 4, 29. There you get your 3SF. Why square root 29? Because if I were to draw a right angle triangle by myself for the point M, over here I'll draw it this way, right? This is my right angle. Here I've got 5 units. Over here 2 units. Then by Pythagoras theorem, this must be square root of 5 square plus 2 square. 2 square is the same as negative 2 square. Same thing. So this is a recap on how we derive the length of a line segment. Alright, part C. If I want the coordinates of R, that means I want to find using vectors OR. Right? As long as I can find OR, I will have the coordinates already. So this is my goal. How will you write OR? Well, OM times 2. Confirm? Confirm? What property are you using? Sounds familiar. Did you come up with that the last time? Yeah, okay. Harith mentioned something like this before. So yes, your OR is actually 2 times of OM. Because by the diagonals of a parallelogram, they will bisect each other. So yes, this will definitely give you the answer, which will be 2 times of 5 and negative 2, which is 10 and negative 4. So the coordinates must be 10, negative 4. Okay, so let me just put it down here first. I want to use other methods just for the fun of it. OR. How else can I go from O to R besides knowing that it is 2 times of OM? Choose any way you like. A longer way. Instead of going from O directly to R, some other way. Shufi, can you suggest a different route? A not so direct route from O to R? O2. What? OQ. Then QR. Okay, very good. This is another way, right? Then what is the vector for OQ? We found out earlier on that it is 8, 3. Then now we've got QR. How do we get the vector QR? QR. Is it the same as another vector already? What is the vector, Uma? QR is the same as OP, yeah, you're right. Because it's a parallelogram, huh? So same direction, right? Same magnitude, okay. So this is 8, 3 plus OP is actually 2, -7. 2, -7. Add them up, we get 10, -4. Exactly the same. Okay? What if we don't use this method to find R? If we don't use Harris' method, we don't use Shufi's method, then I want you to find coordinates of R. Any other suggestions? OP, then PR. Yes, that's another one. Where PR is the same as OQ. Then OP is the same, right? You get the same vector. Another way. One last way. OM plus MR. But for that, you need to know the coordinates of, you need to know the vector of MR, which we don't know yet. Can we try doing it using simultaneous equation? I don't want you to do it now, but you think about how to do it. Now we are going to try 20. I'm going to skip the example for 20. We just go straight into this question. So, AD is equal to negative A plus D. And we've got BC, negative C plus B. Negative B plus C. Alright, managed to get this? Do you notice a pattern? If I want, for example, A, D, then my answer will be negative A plus D. If I want B, C, then my answer will be negative B plus C. Have you discovered this yourself? After you've done quite a few, you should realize this pattern. But it only works if they label it as such. OB is vector B, OA is vector A, OD is vector D, and OC is vector C. Most of the time it's going to be like that. Next, part B. Show that vector D equals to A minus 2B plus 2C. Is there a part of the question that is there an information in the question that we haven't used yet? Okay, which phrase is that? AD equals to 2BC. That's the clue. In maths, we don't like to give you extra information. Almost every information will be used. So how do we apply that to our answer, to get our answer for part B? What have we been searching for in part A? A, B, AD, and BC. How about you try rewriting your answers from part A? Substitute into the equation highlighted. AD equals to 2 times of BC. Why is it that we can say this? It's given? No. Did they say that these two vectors are, vector AD equals to 2 times of vector BC? They didn't say that. So why is it that you can say that these two are equivalent? You look, what did I highlight? AD equals to 2BC, right? This is referring to length. Yeah, but they're not talking about direction, isn't it? So Dharmiya says they are parallel. How do you know they are parallel? Because the question says it is a trapezium. So because I know that these two are parallel, therefore I add it to the fact that the magnitude is double, so I can write this as my first step. Okay, we're going to do try 21 now. As usual, we're going to skip the example because I think you can follow by trying yourself. So recommendation, follow it. I'm sure you'll be fine. So from O to E, instead of going directly, how else can we go there? O to C, okay, fine. O, C. Then from C to D, E. There you go, step by step. Do we know OC already? Yes, so our problem now is CE. Okay, let's write down OC, that will be C plus. Now C to E, how much is C to E? What's the information given? 4 and 3. So CE, I'm going to rewrite it now. I am going to rewrite CE to be, C is a fraction of another vector, right? What is a fraction? What is that fraction then? 4 over? Are you sure 3? 7, yes. It is 4 over 7 of another vector. What is the other vector? CE is 4 out of 7 of another vector. What is that vector? CD, yes. It doesn't take a lot of effort to be able to write this down. Because we drew it out already. We can see that's 4 units, that's 3 units. Then it must be 4 over 7. So all these steps don't need you to put in a lot of effort. But as long as you write it down, then things become much clearer already. 4 over 7 of CD. Okay. What is the vector CD? From C to D. Instead of going directly from C to D, yes, negative C plus D. And what is the answer? C minus 4 over 7. C must be 3 over 7C plus 4 over 7D. This is the answer. Alternatively, you can leave it as this. 1 out of 7, 3C plus 4D. Both are acceptable. Can? Now this question, I want you now to find the area of OCE over area of OED. Is vector A parallel to 2A? Are they parallel? Yes or no? Or maybe? Yes, no, or maybe. Who says yes? Raise your hand. Yes, okay. Who says maybe? And who says no? Then we have the answer already. Although some of you didn't raise your hand, but I hope now it is clear to you that they are parallel. Okay, these two are parallel. Now I'm going to change the question. Is vector B parallel to half of B? Yes or no? Very good. Is vector A plus B equal or parallel to half of A plus B? Are they parallel? Yes, they are. How about A plus 3B over here with a 3B over here? Are they parallel? Yes, they are parallel. So this is how we can use vectors to prove that they are parallel. As long as you can write one in terms of the other, then they are parallel. One in terms of the other being in a scale factor, scalar multiple. So now I want to sketch it out so that I know which vectors to compare. If I don't sketch, I could be comparing PQRS. I could be comparing PQ versus RS. I could be comparing QR versus PS. I don't know what to compare. So a sketch will help me. P, 4, 3. So 4, 3. This will be my point P. Q, 6, negative 3. 6. Try to draw it to scale as possible. Q, R, 2, negative 5. So 2, negative 5. And S, negative 4, negative 1. Okay, join them up. Yeah, I didn't draw it very well. Huh? Oh, 4 is, yeah, okay, thanks. R. 4, wait. R is 2, negative 5. Okay. Wait, is my P correct? 4, 3, 6, negative 3. R is 2, negative 5. 2, negative 5. This is R. And S, negative 4, negative 1. Okay. Is it correct now? Okay. Now, is it clear for us to see which sides are parallel? Yes, right? Because just now when I drew that nonsense, I couldn't really tell, so I know something is wrong already. So, now my job is to prove that SP is parallel to RQ. Gaius, what is the vector for SP? Part A. SP. Give it to me in terms of addition of two vectors. SP, S to what? There's an O here, which we have all the position vectors because of the reference point O. So SP, how do we rewrite it? The junior help you already. What's the answer? What did he say? What? Great, tell me. Tell me what he said. SO plus OP. And it is useful because we already have the position vectors. So SO is the same as negative OS. So just change the signs quickly. What is the value for SO? 4, 1. OP? 4, 3. So this is 8, 4. Okay. And the next one, since I have SP, what do you think I should find next? RQ or QR? Or doesn't matter? RQ or QR? Or doesn't matter? Decide. RQ? Okay, let's find RQ. So, let's try again. RQ, what is it made out of? You need help? You need help? Umar, you want to help him? You sit there, laugh. Come, help him. RO plus OQ. For the same reason, we've already got the position vectors. Very easy. RO, how much is that? RO, negative 2 and negative 5. 5 plus OQ. How much is OQ? 6, negative 3. Okay, this gives us 4, 2. Now looking at these two vectors, what can you tell me? Are they parallel? How do you know? This is not enough to tell me they are parallel. You need to have one more step. Okay, wait. Let me put it down here. SP equals to 2 of RQ. Can you already see that? Okay, from here, we go to this step. SP is actually 2 times of RQ. Then you conclude. So, SP parallel to RQ. Therefore, it's a trapezium. Get it? Then, I want to bring you back to my previous question. We were deciding, should we use RQ or should we use QR, or it doesn't matter? So if we chose RQ over here, we see that hey, it is equal to 2RQ lah. What happens if I chose instead QR? What do you think the answer will be for QR? Compare. QR, what will it be? Come on. Huh? -4 and -2. Agree? Because change direction only ma, so all the signs change direction lah. So if I have QR looking like this, then I can say that SP is equals to, is it still 2 times of QR? Then what is it? Are they the same? No, right? So what must I do to make them equal? -2. So when I do this, it tells me that hey, they are opposite direction. But they are still parallel, right? Then it still works. Okay, next. Part A is done already. Okay, let's put this back. SP is 2 times of RQ. Okay, that was our conclusion. Now for part B, find the area of PQR to RPS. What? Good thing that I sketched it out. So PQR, this triangle to PRS, okay. So yellow to green. What is the ratio? Then I give another clue. You are supposed to make use of this information. So I will do it this way. SP, the magnitude of SP divided by the magnitude of RQ equals to, so I put it over here this way, equals to 1 over 2. Now it is very clear. Which one is the 2 unit, which one is 1 unit? RQ is 2 units. What? Oh, hey, this 2 over 1 lah. SP over RQ, 2 over 1. So which one 2 units? SP must be 2 units over here. This must be 1 unit. With this, how do we find the ratio of the area? Like what yours suggested, right? 1 is 2, but why 1 and why 2? Are they similar triangles? No, they are not. Do they share the same common height? Common height? Yes, they do. Where is the common height? What? P, R? No, the answer is we don't know where is the common height because, or rather, we don't know whether PQ is the common height because they didn't say that this is 90 degrees. They didn't say that this is 90 degrees. Okay, so instead, what you should be saying is, if I draw a vertical line over here, it will be the same vertical height because this SP is parallel to RQ. Therefore, they must have the same perpendicular distance between them. That is our perpendicular height. And that is why, for part B, the answer is 1 over 2. No working required, it is simply 1 over 2. Okay? Let's try, very long, huh? Try it 23. Read the question. Okay, Q. I don't accept this. -15 plus 5, 4 plus 8. Not accepted. Answer is correct, right? But not accepted. Because if you're dealing with vectors, you should be using vectors. So part A, I want OQ in order to get my coordinates for Q. So OQ is given by OP plus PQ. And I'm sure that makes sense to all of you. Then OP, I've got a position of P. So I've got a position vector of P. This will be -15, 4 plus PQ, 5, 8. Giving me -10, 12. So Q will be -10, 12. This is the presentation required. Okay, this, if you were to stop over here, you won't get a final answer because you're not showing me the coordinates. This must be the answer. You must convert from position vector to coordinates. I'm sure you know the logic behind the working. It is the presentation that will cost you marks. Now find the coordinates of R. Let me put down Q, this is negative 10, 12. So R. What other information from the question have we not used yet? What about RS? RS equals to 2PQ, okay. RS equals to 2 times of PQ. And RS, okay, PQ we found that it is 5/8. So this one, the right answer is done very easily. RS, I want to find the coordinates of R, which is actually embedded inside RS. Can you see it? How do we obtain the coordinates of R from the vector RS? Can I break up RS? Break it up to become what? RS is actually R O plus OS. Can you see that? And what is the point of writing it this way? This is what I need in order to find the coordinates of R. Because for the coordinates of R, I require OR. You know, if I can find RO, I'm sure I can find OR. This must be going through your mind. Then this one, we said we have it already. OS, we also have it, right? Then, done already. This is equals to 2 times of PQ. So let's put everything in. RO plus OS, OS 64 equals to 2 times of PQ, which is 5/8. RO must be equal to 10 minus 6 is 4, 16 minus 4 is 12. This is RO. Can you now tell me what is coordinates of R? Mentally, what is it? Negative 4, negative 12. Then look at your diagram. Does it make sense? Negative 4, negative 12. Yes, right. It looks like it is proportional. So from here, my next step is actually OR equals to negative 4, negative 12. So R must be negative 4, negative 12. C part 1, QT in terms of T. QT equals to QP plus PT. I saw most of you do this. For that, yeah, you already have QP. But you need to find PT. This is your problem over here, which can be done also. But Sinlin has an easier way. How about we go from Q to O, then from O to T instead? Isn't it better? Then do you know what QO is? How much is it? Did we find Q just now? Yeah, negative 10, 12, right? So what is QO? Who said 12, negative 10? 10, negative 12. Plus OT, how much is OT? OT? T4. So this must be 10 plus T and negative 8. So this is the vector QT in terms of T. If you did it the other way, from Q to P, then P to T, you will still get the same answer if you don't make mistakes. Now part 2, find the value of T.